Morning, everybody. Here we are again, coding on Swiboe, the next generation text editor. I hope you all had a wonderful weekend. I had a great one. And yeah, let's dive right into it. So, what happened to Swiboe over the weekend? A couple of things. So, the first one is we now have a Gitter client, a chat room, I guess. So, what is Gitter? Gitter is a service that provides an ISC like chat room for projects, but the chat room is persistent, so you can scroll back and see when people have messages before. So that's kind of cool. And what I really like about it the most is that it was actually a issue that was opened in the on our repository. So the first issue that was opened against Swiboe, it was asking for this chat room, and so I made one. So what else? This is the pull request I made last week. I presented it on Friday, I think. This making Swiboe work over the TCP connection. And the really exciting thing about this is that Greg Chappell, I asked him if he would code review that, and he actually agreed to doing that. And he already had a bunch of good comments here. That is really exciting. I would really like to establish a code review culture similar to what the Rust compiler project has. So that code that gets checked into Swiboe is always reviewed by at least one person, so that like two pairs of eyes looked once over the code. I think this is really beneficial and guarantees that the quality of the code is really high. So Greg, for all those people who don't know him, Greg is actually the guy who wrapped Rust Termbox, which is the GUI library that we're using in our terminal GUI. So basically, Greg provided us with Rustbox, which provides us bindings to lib termbox, and that makes for a really cool programming experience on the terminal. So Greg has already been very useful for this project, and when he does more code reviews, he will become even more useful. So thanks, Greg. And what else? Oh yeah, I actually over the weekends I did some organizational stuff. I added some strawman docs. They are not really that interesting. All they contain is essentially a to-do. Yeah, I think that's all there is. Let me see. Where is it? Here. That's our index documentation so far. And all it says is to do, nothing here, still figuring out the logistics. But the cool thing is, whenever we now push to the Swiboe repository, we will actually get this documentation built and updated here on Read the Docs. So we have now Swiboe documentation on swiboe.readthedocs.org, and you can see, of course, there's not more content than was in the file, but this all seems to be working, and that is really nice. So I imagine that we write our request for comments in this documentation, and also, of course, like the user documentation will eventually end up here. And it's really important, in my opinion, that the code and the documentation is next to each other in the same repository and updated at the same time, because otherwise it will just diverge. And I think that is it. Hey, Parts, good morning. Yeah, I think that is it with the top of the show business. I think we can jump right into coding. Is that right? I feel like I had something else. Let me look at my list. Nope, precisely. We can start coding. So I actually decided to not work on the stuff that I do on stream off stream. So like there's so much that can be done on Swiboe that I always have something else that I can work on off stream. So that means that the streams will stay logically consistent. So if you always watch the stream, then you will always see the full story of the particular topic that I'm working on. And I think that is actually easier to follow. But like, just let me know what you think about that, guys. I would be really interested in that. Last Friday we actually ended on a low note somehow. because I actually ended the stream with a non-compiling version of the code. And I would say we actually go back and fix that and revert some stuff to make it compile again. Basically, what we had compiling was that we said our function here, our callback function, it returns a pointer to a char, and it takes an integer, and then basically it doesn't take a string pointer. All it does is it returns a new string that is made up of a constant string and the argument that we pass into the function. And here in the C++, in the Rust code, we actually, I think nothing has to change, right? We call the function, but we don't call it with a mutable pointer. We call it just with a integer, and then we get back a C string, a C buffer, and we also have to define what we get back. So basically this function returns a const pointer to a C char. And this C char is not owned, so we make a C string out of this buffer. We convert it to a UTF-8 slice, and then we print it out. So, and that worked, but I hope, yeah, see, that worked. So basically, here we have this print out of in Rust that is here before we call our callback, then we call the callback, and then we get back the string hello again 42. So that all worked, but we get this really ugly warning here. Runtime warning, memory leak, and callback function. And that's something that I tried to look into over the weekends, and I learned that you can actually change that. Yep. There is no way of asking Python to give you a C string and at the same time free the memory like for everything around it. Basically what we would like to have is that we get back a allocated buffer that is just the 0 terminated C string object, and all the reference counting and what else Python does around that to make it a valid Python string, we'd really like Python to drop. But unfortunately that is not possible. So there is really no way of actually passing ownership of an object from Python into the C library. So what is the correct solution to that then? Well, the correct solution to that is to actually make a proper object and create that in Rust, and then return a pointer to it to Python, and then let Python eventually pass this pointer back to Rust, and Rust can destroy it. So did that make sense? I don't know. Well, we'll see how that works. So basically what I'm talking about is we make a new structure that is public, let's call it test, and that has just something in it, right? I want something in it, otherwise it is a zero-sized object, and those are always special in Rust, and special is not good right now. We want something that just works. And basically what we now want here is we want a new function, and this function will be used to create such an object, right? So it will be pub extend c fn, and we call it creatively, we call it create. And actually let's make this usize here, that will be a string object, right? So create actually now takes a string from C, so like a C string object, so a 0 terminated buffer, and the function also has to return something, right? Because we want to create such a test object, so it has to return a mutable pointer to test. And that is like it's not a owned object or what else you have, I don't know. That is basically we return a pointer to an object, and then we have to make sure that basically Rust is not deleting this object immediately when this function terminates. So how do we do that? It's actually pretty simple. So first, let's copy over this stuff here. Basically, so we already have the C buffer, but we create again a C string from pointer. That should always work, and then we create the string buffer. But now we actually would like to create a own string, right? Because the test object should eventually own that. and that is basically a string from UTF, and that takes a buffer, and we just unwrap, right? No, actually, let's do it differently. Let's actually keep this down here like so. So basically we create the string slice, and then down here we create somewhere our test object, and here we say string slice into, right? And that will actually create a string and copy over the data from string slice into this new string, and then the string zoned. So basically something like that. Our function should look something like that. Except of course that won't compile, right? Because we say that we return a pointer to a mutable pointer to a test object, and here we create a test object on the stack, and we cannot return a pointer to this object on the stack because the stack will be destroyed when the function terminates. And when the function terminates and our stack is then destroyed, then of course the pointer will point to invalid memory, and that is that sucks. That is not working, right? So basically what we definitely want, we want an object on the heap. And to make an object on the heap, you create a box in Rust. But that won't work either, right? This won't work because at the end of the function, now Rust will destroy our box, and then we can still we still don't have something to point to. So basically what we have to do, we have to basically say, please Rust, give me the pointer back, but don't destroy it. And the way to do that is actually to say, well, mem transmute me this object here, like so. And that looks terrible. Let's keep it like that. And mem transmute, of course, that's so unsafe, right? So we actually have to wrap that in an unsafe block because it won't compile. So what do we tell Rust now? We basically say, please create me a box, which is a object on the heap, and then transmute this box object into a raw pointer and return this raw pointer. And this transmute actually, since the raw pointer is when it goes out of scope, Rust does nothing with it. Actually, our object is not deleted. So if you only call create, this will actually leak memory. Let's see if that compiles. So it doesn't like that we didn't include mem. So use standard mem, please, and sort. And system memory. Why did we include that? I don't remember, but we don't need that anymore. And some unused fields. That is fine though. And okay, so the Rust part that actually compiled. And now I would like to actually change the callback function down here, this one. I actually would like to change that so that it returns one of those objects, right? So basically what I believe we will need doing in Python will look something like this. Here we will return something like Swiboe callback, something like that, right? No, not callback, sorry. Create, right? Basically, the callback now returns one of those, like a pointer to one of those test objects, and we create the test object here. So we change this to actually the callback function. It returns not a pointer to a string. It actually returns a mutable pointer to a test object, right? Like so. And now we actually, inside of our callback function, we would like to get back to the box somehow, right? So we have two options basically. We could say something like our test object is we first call callback, and that gives us a test pointer, right? And now we could say, well, I would like to have not a test pointer, but I would like to have a mutable reference to test. And that will work like that, like transmute, something like this. And of course, that is also unsafe, right? Because we say, we tell Rust to take something and then just like convert it into something else without really looking at the data. So if we get something else from our callback back, if that callback returns a 0 pointer, for example, that would crash. And there's nothing you can do about it. It will just crash. And if we write it like that, so if we take a mutable reference to a test object, that means that when this mutable, like when test goes out of scope, Rust will not destroy our object, right? Because it doesn't know that it owns that object. And that means that we will still leak memory. So in this case, we actually would like to destroy the object at the end. So we say, well, actually, we don't want a mutable reference to an object. We actually would like to get our box back, right? The box that we created here, we now transmute back into this box. And as soon as this object goes out of scope down here, Rust will drop this box, and that will actually free the memory. And we can actually convince ourselves, oh, no. Let's go one step at a time. So let's keep this in Rust pointer to make sure that this is still happening. And now we have to go into the Python code, and we have to provide some information. So for example, we have to say that create returns a C void pointer, right? So just some pointer is returned by create. And we have to say that our callback function now not returns a C char pointer, but it also returns a C void pointer. And C type C void pointer, right? And I think that should be it. So we build, and then we run. And then what does it say? It says rest type must be a type, a callable on none. And it's right, it should not be an array, right? So let's try again. And you can see that actually nothing crashed. We have our in Rust call here, so we actually called the callback. That also means that we ran through as we create, and nothing crashed. But did we actually get a valid box object back? Well, we can check that really easily by printing out test.a, right? Basically, the variable that we assign to our test object up here, we can just print it out and see if we got a valid object back. And you can see, wow, we actually got a valid object back. Hello again, 42. And we can also make sure that the object is dropped here at the end of the function by just implementing drop for this struct here. So implement drop for test. Drop takes itself as a mutable reference and returns nothing. And here we just print line test got dropped. Yeah, that should work. And now we expect, and there we go. Here, after the function ran through, so after we printed out this line, test actually got dropped. And the string, like first we print the string and then test got dropped. So now our memory is freed, everything is wonderful. And just to like show what I meant earlier, if we basically say like test is not, it is not a box, but it's just a mutable reference to a box. And if we run it now again, it will still work, hopefully, and it does. But since we don't own the object, we don't drop it at the end, and so our current code leaks the memory. So let's go back to this one. Yeah, and I'm really, hey Laszlo, good morning. I'm really, really happy with how that looks. Yeah, I think so. I think that is probably all that we need, right? We can now go ahead and start implementing our C client. Let me think real quick. So we know how to pass Unicode strings from Python to Rust. We know how to create objects in Rust and how to actually return them to Rust for destruction. So all of that works. Unfortunately, we have like zero type safety in here, right? We basically just say, well, our create function, it returns a void pointer. And here, this callback function also returns a void pointer. And just by convention, we basically like assume that the right void pointer is passed around But of course, if the user, even in Python code, makes a small mistake here, everything will just crash and burn. And actually, I believe that ctypes allows you to define opaque data types and then to pass pointers of those around, and then ctypes will do some checking that you have the right pointers. But in the past, I have been bitten really badly by that because it didn't quite work, or in some cases, ctypes actually forbade you to pass around some of those pointers. And yeah, that is definitely not something that I would like to deal with at this point in time. I'm fine with no type safety whatsoever. I mean, after all, it is Python, right? There is no type safety in this language. Yeah, so let me commit this state real quick. And then we go ahead and we can actually implement our client, right? So basically, we want something like a connect function here instead of a create function, and it will not return a test, but it will return something like a pointer to a Swiboe client. So here we want extern create Swiboe, and here we say use Swiboe client. And just let's see if it actually finds Swiboe like that. Fetch result, use of undeclared type or module client, it says. And, oh, because of this, right? We only want to use the client. And it compiles, but of course now this will all crash because we're not actually returning, like, yeah, that you can see the power and the danger of unsafe here, right? Basically, we construct a object down here, and we have a box of this object, and then we say men transmute, and Rust just like happily transmutes a pointer to one kind of object into the pointer of another kind of object, and of course that won't work, right? That will crash really, really bad. But yeah, nobody's to blame for that except for us because we're using unsafe. But we have no choice. We have to use unsafe. So how to construct a client? A client is constructed through a new call, pretty sure. Oh, a connect call, and the connect call takes a socket name, and that's it. So basically what we would like to have is, basically we get here a C string, and that is the socket name, and then we finally pull out the function C string to string, something like this. And that takes a C buffer that is a const pointer to C char, and it returns a slice, a string slice, right? And that is essentially just this here. And yeah, so it takes this works always, this works also always, but this doesn't work all the time, right? Basically here we do an unwrap, but do not unwrap, do error handling, right? That is really important here, and we will actually look into that, I think. And then here we basically say our socket name, that is actually a path new from C string to string socket name. That should work. And we use standard path. And then we say we have a client, and that is actually a client in a box, right? Because we have to return a pointer to it. And then we say client connect, socket name, and that is probably also returning, yes, it's returning some error. So we also unwrap here and say error handling. I plan to do error handling on this relatively soonish, so so I don't leave all those no comms in here. I really would like to polish the C client a little bit so that we can build useful abstractions on top of it without constantly breaking our API. But for now, until we actually have something that connects somewhere, we will keep it like it is So here we return mem transmute client, right? And then we would like to have something like poop extern, something like delete, cleanup, close. How would you call that, guys? Actually, we don't have any functions to, like, our client doesn't offer us anything to actually call it, like, shut it down at this point in time. It waits until the server shuts down its connections. And oh, there's something like drop here though. So if we actually drop the client, it will disconnect. That's fine. So we can actually say something like pop extern cf in connect, and then we like called it disconnect, and then we'll actually also delete the client. And it takes a client which is a mutable client pointer, and here all we need to do is, and it returns nothing, of course, because the client cannot use anymore after this. And what do we do? What do we do? We just transmute that. We transmute it into a client box pointer, right? So the mem transmute client, like so. I think that's right. And basically, what we tell Rust here with this is that we are not actually interested in using this this thingy for anything anymore. It just can drop it after the fact. We could also do something like this and say, well, transmute it please into a box client, and then it will drop it after the fact. I think that is probably nicer. That reads a little nicer. And then, like, we don't need this hello stuff anymore. We don't need test. We don't need, like, all of this goes away. And now we build. Failed to resolve. User undeclared type or module client. And that is correct because that is called client, right? And down here too. And what else? Missing lifetime specifier. How does that work though? I mean, basically what it's complaining about is in our function, oh, we don't need hello anymore. In this function here, we give it a const cchar pointer, and raw pointers don't have a lifetime. So, and then we return a object that must have a lifetime. And I'm not sure how that works, because, I mean, to which lifetime should we bind this return value, right? I'm really not sure how that should work. Okay. Let's cheat our way around that by saying, well, we return an own string here, and that means that we actually like to do this always makes a copy, even though it might not be needed. And I actually have to look into how we can specify those lifetimes correctly. And that was it, I guess. No, still unhappy. So first here it would like to, actually we have to pull that out now here, and we have to say this is our socket name, and that is actually, the function is no longer, that's now called cstring to string, something like this. And we create our socket name like this, and here we actually take a socket name path, and that should be it. Too few type parameters provided. Accepted 2 parameters, found 1 parameter. What? What? Mem transmute client. Let's try it like that again. So client call to unsafe function. Yes, you're right, that is unsafe. Let's box it into an unsafe block, and now it works. I don't know, maybe transmute takes more arguments than I was giving it, and it couldn't infer all the other arguments, but that now works. And over here we still need our C-types library, but now we actually start to being a little more precise and actually define the functions that we have. So we have a connect function, and that actually it returns a C void pointer from C types import C void pointer. Yeah, that's all we need for now. And a C sharp pointer too. So, and connect takes, so archetypes, I think it is, are like one char pointer, right? And then we have, it's not, it is Swiboe connect, right? So we have the connect function now. That is now defined. And now we have the disconnect function, and that takes one void pointer. And let's be precise here and say that actually it returns none, right? And that should be it. That should be it. So basically, if we now say as we connect to temp bloop.socket, and then we time sleep for 5 seconds, and then we call, oh, that's actually our client, right? We have to hold on to that, and then we say client disconnect. Then that should work. Oh, it's actually not client disconnect, it is actually Swiboe disconnect client, like so. And actually, I don't like that I abbreviated Swiboe, so let's write that out, Swiboe. Now we still need to import time. And now we have to build this. And of course, we also have to run a server. Doesn't have to be in release mode. And no TCP, please. Okay, and now 5 seconds and core dump. Yay! So what did happen here? So interesting. So it is complaining about the from pointer function. So probably Apple is not interested in this particular core dump. So what did I do wrong? I basically say connect takes a char pointer, and then we did do the same that we did before. We basically create a C string object out of that, and then actually we can simplify this and say we make a string directly out of that, like so. And let's introduce some alive prints here, just to make sure that we know where we are. What's up? Oh, actually that simplification doesn't work because we don't own those bytes. So string from vector will actually try to duplicate, try to consume the bytes that we give it, but we don't own the bytes because they're owned by the C string object. So that doesn't quite work. Yeah, so I'm still rather confused why this is actually crashing. Thirteen, 15, 17, 19, 13? Wait a second. Wait a second. 13, 15, 17, 19? That's fine. But then at 13 again, do I call this function twice? No, I don't call it twice. Guys, what's going on? What is going on? Why are we again in 13? Are we calling connect more than once? No, we're calling connect, like apparently we're calling connect twice, but I don't understand why. Let's add a little more tracing here. So, yes, we know it crashes. 25, 27. So 25 is probably this one here, right? Yeah, that's correct. 25, and then we jump into 27, and then we jump into 13, 30, here, 30, and then we're jumping in 25 again. What? What? How can that be? That makes no sense. What is going on? Really, I don't understand that. I really don't understand it. So I connect here, but this function, like, why do we, like, is it because it's connect? No. Let's call it something else then. But I cannot believe that this is the issue. No. Looks very much the same. 30, 35, 37. Or does it? No, it actually looks different. What? 30, 35, 37. Are you kidding me? How can that be? Basically, if we like call our own function connect, then this connect call will actually call our own function. I mean, that feels like a bug to me, like a bug in the Rust linker or I don't know what. But I mean, like if I rename this function to connect, right? And I recompile and run this, then it crashes. If I call this something else, for example, create client, then it runs through. That is really weird. Well, I mean, yeah, I mean, do I really care if this function is now called connect or create client? I don't, but really I would like to understand why this crashes. But well, I mean, we're already like, we're over time. Actually, I always try to go for around 30 minutes. We already have 40 minutes now, and I think we're at a good spot. So like, let me remove real quick all of those tracing. So all of this tracing is gone, and basically what we have now is we can run our Python client, and it will actually connect to the running server. It will sleep for 5 seconds, and then it will disconnect. And as you guys can see, it all works. It's not crashing anymore. So I think that is a really nice stopping point, and then tomorrow we can try to figure out why it's actually crashing. So let's add a to-do here. To-do, this crashes when the function is called connect, actually, if the function is called connect. Okay, I think that's all for now. I see you guys tomorrow. Bye.